Alright, so today we're doing lesson 7.4 in our package called Rational Exponents. Rational exponents are just fractional exponents, and we've talked about these before. I've mentioned that, say, 4 to the power of 1/2 is the same as the square root of 4. Okay, I'm going to prove that to you. So I'm going to do this with a bit of a different approach. So this is what I've said. I said the square root of 4, and that just equals 2. And I've said that this is just 4 to the power of 1/2. Well, let's try this, but let's not assume it's 1/2. Let's just say this is just 4 to the power of something we'll call x. Alright, now I'm going to change 4 into a base of 2. So 4 is just 2 to the power of 2. So that's just 2 squared. And we still have that x there. And we're just going to keep that 2 on the right side. Now here we have a power to a power, so we're just multiplying that. So we have 2 to the power of 2x equals 2. 2 by itself is just 2 to the power of 1. Now for this to be true, for this statement to be true, we now have the same base, but the exponents must also be the same. So we need to write that 2x needs to equal 1. Now you can probably see it there. If I solve for x, divide both sides by 2, x equals 1/2. So going back up here, we can rewrite this as 4 to the power of 1/2. Alright, now most of this sheet just asks you to rewrite things going back and forth between rational exponents and square roots. However, I want to go over, say, example number 2 on the back, which actually asks you to evaluate without using a calculator. So how are we going to do that? Not our calculators. Anything but our calculators. Okay, so let's try the first one. It says 64 to the power of 1/3. Now there's a couple of ways you can attack each problem. You can write this as the cubic root of 64. And if you know the cubic root of 64 is 4, then great, you didn't use a calculator. But I'm going to do it a different way. I'm going to rewrite 64 as 4 cubed. Because I know 4 times 4 is 16, times 4 is 64. Kind of the same approach though. Just looks a little less intimidating. Okay, and now power to a power, we multiply. So 3 times 1/3 becomes, well, 3/3 or 1. So that just gives you 4 to the power of 1, which is just 4. Okay, let's try one more. Let's do E. Let's do E, the hard one. So 27 to the power of -2/3. All right. First, let's deal with the minus. Now remember, minus, you sort of just flip, take the reciprocal. So I can write this as 1/27 to the positive 2/3. Okay, now 2/3 is the same as a square and a cubic root, 1/3. What I can do is I can apply one of them first. Now I don't really want to do 27 squared first because I don't know what that is in my head. So let's do the cubic root. Let me write this as 1 over the cubic root of 27. And then we still have that squared there. You would apply it to the numerator as well, but because it's 1, the cubic root of 1 is just 1, so it doesn't change. And the cubic root of 27, or what number multiplied by itself 3 times gives you 27, is just 3. So now we're left with 1/3 all squared. And the square is going to apply both to the 1 and the 3, but again, 1 squared is just 1, and so we end up with 1/3 squared, or 1/9. Okay. So try the rest of the problems yourself. I think this is the third lesson for this week, and I'm not going to do more than 3 lessons per week, and we'll have plenty of time to finish. So try that for yourself, and then check your answers. I will post them alongside the video. And have a good weekend.